Hello everyone, welcome to All Chemistry, and I am again Hofmann. So
back.
today we will discuss about
this
some
session-
amine formation reaction. And in this amine formation reaction, basically I will discuss the amine formation on the basis of some rearrangement reaction, and that rearrangement reactions are very important for any kind of examinations. So in that four rearrangement reaction, we will at first we will summarize the whole that four rearrangement reaction in a four part. That means what is starting material and what is reagent, then what will be the product. So we will summarize it at first, then I will discuss the first rearrangement, means Hofmann rearrangement reaction. Okay, let's start. Okay, so we are discussing mainly these four reactions in this session. So I will discuss about these four reactions basically in this session. So today I will discuss about Hofmann rearrangement reaction in details with mechanisms. And here you can see we have Hofmann rearrangement, Lausanne rearrangement, Curtius and Smith rearrangement. Now in Hofmann rearrangement we have amide as starting material, and we have bromine in aqueous alkali. So we have taken here potassium hydroxide. You may take here sodium hydroxide also, and we are getting amide as product. Then in Lausanne rearrangement, we have O-acyl derivative of hydroxamic acid as starting material, and reagent is hydroxide. Means rearrangement is any reagent is any base, any aqueous base, and product we are getting amide. Now in Curtius rearrangement, we have acid hydrazide as starting material, and as reagent we have HNO2 and heat. Then after that we have to add base to form amine from that isocyanate intermediate. And in the last case we have Smith rearrangement, and in Smith rearrangement we have carboxylic acid as starting material, we have reagent that HN3 hydrozoic acid and H2SO4 and base, and we are getting product, we are getting amine as product. And the common thing about all the reactions, about all these four reactions, is these four reactions gave us amine as product. And another thing is all these four reactions have intermediate isocyanate. In all these four reactions have intermediate isocyanate. So isocyanate intermediate, so they pass through isocyanate intermediate. So now in Hofmann rearrangement, first of all we have amide, and we are adding here bromine in aqueous alkali. So we can take any alkali in aqueous medium, means potassium hydroxide, sodium hydroxide, and we are getting amine as product. Now here you can see what about the reaction mechanism. So let's see the reaction mechanism first. In step 1 we have bromine, and we have base. So that base will attack, actually when there is bromine, 2 bromine. So 2 bromine we can think it as maybe there is no electronegativity difference in that, but we can think it as delta positive and delta negative. So HO minus will attack. So in the transition state we can think it as of delta positive and negative. So bromine HO minus will attack at delta positive, and one bond will break, and we will get HO Br plus Br negative. Now clearly we have HO, OH and bromine. So when there is OH and bromine, delta negative will get that OH and delta positive will get that bromine, because that oxygen more electronegative than our bromine. So OH got delta negative, and bromine got delta positive. Now here in the next case, what will happen? In step 2, we have our amide. Now that hydrogen, we can think it as acidic hydrogen, because if OH negative takes up this hydrogen, a negative charge comes on nitrogen, and that negative charge will be stabilized by resonance or by minus R effect of this carbonyl group. Now it will form like RCONH negative. Okay, so as you can see, RCONH negative. Now here we have OH bromine. This complex we have, or this substance we have. So now by negative charge of nitrogen, it will attack to the delta positive bromine, and this bond will break. So let's see the next step of that reaction. So here this is continuation of step 2. Now this negative charge of nitrogen attacks to bromine, and this bond opens up, and this forms, and still there is base present in the medium. So that base also captures another acidic hydrogen which is present with nitrogen beside of carbonyl group. So it will capture that nitrogen, and again a negative charge will come on nitrogen atom. Now in next case, that forms basically N negative and bromine. Now here the rearrangement actually happens. How? Here that negative charge come towards carbonyl because it is resonance stabilized towards carbonyl. Now that carbonyl bond opens up, and this bond again is closed up, and then to manage the valency of carbon atom, this group which is attached with carbonyl carbon will be shifted towards nitrogen, and this bromine goes out from the substance. Now what happens? There was negative charge on nitrogen atom. This negative charge goes towards carbonyl carbon, and again this bond, bromine bond, breaks. That means that is actually happening. R is coming with nitrogen, so negative charge come towards carbonyl and carbon. So that means that if I erase this, so that means negative charge come towards carbonyl, and R group goes towards nitrogen, and bromine goes out. So actually that forms C double bonded O double bonded N with R. So this intermediate is called isocyanate intermediate. This is isocyanate. So this will be called isocyanate intermediate. Now after this isocyanate intermediate, if we hydrolyze this isocyanate in presence of base, then we will get amine. Let's see it. Now in step 3, we have isocyanate intermediate R in double bonded C, double bonded O. We have base here in the medium. So that will attack here. That bond again open up, again closed up. Then a negative charge on nitrogen again. And as we have taken aqueous alkali, so here is water also present. So from water, nitrogen will take up proton, and here also OH comes. So actually what happens? It becomes R NH C double bond O OH, and in the medium base is present. So HO minus will come, and decarboxylation will occur, and we will get our desired amine here. So this is the whole process, whole reaction mechanism for Hofmann rearrangement reaction. And thank you for watching. And don't forget to like, share and subscribe. And again, thank you for watching.